So we're told that S of t is the position function of a particle moving on a horizontal line. So there's some particle just moving back and forth left and right. And we want first the velocity and acceleration functions. Well, velocity is equal to the derivative of a position function. So the velocity function would be 6t squared minus 12t. And acceleration is the second derivative of a position function. So that would be 12t minus 12. Determine the time intervals on which the particle is slowing down and the intervals on which it is speeding up. So when is it getting slower and when is it getting faster? All right. Well, let's first figure out when it's 0. So when does the velocity equal 0? Or when does 6t squared minus 12t equals 0? Well, this occurs after we factor when t equals 0, when t equals 2. So in terms of the velocity, we know when it equals 0, 0 and 2. And we know that when t is 1, the velocity would be negative. That when t is 3, the velocity would be positive. And when t is negative 1, the velocity would also be positive. We're really interested on the interval negative 2 to 3. Now, this doesn't quite answer the question when the particle is speeding up or slowing down, because we addressed the velocity. But if we reason through this just a moment before getting to the real question, if the particle has a negative velocity and then goes back to 0, so somewhere in here it's at its most negative, which means it's going left the fastest it's going to go, and then it's slowing down, reaches 0, and speeds up again. So it's going to the left the fastest it's going to go to the left, somewhere in here, and then it slows down until it gets to 0. Then it speeds up again after 2. If we would consider the acceleration function, when does that equal 0? Well, 12t minus 12 equals 0 when t equals 1. And again, using some sign analysis, we know that at 1 it equals 0. That when t is 2, the acceleration would be positive, and when t is negative, or when t is 0, the acceleration would be negative. We really need both of these things. Right, so I'm going to line up the acceleration sign analysis to make a determination here. So I can see, since we're starting at negative 2 and going to 0 first, that from negative 2 to 0, the velocity is positive. So that means we're moving to the right, but the acceleration is negative. So the acceleration is in the opposite direction. So this would be when we're slowing down, because velocity and acceleration are working against each other. Then we can see from 0 to 1, velocity is negative and acceleration is negative. So this means it's speeding up. It's getting faster in the direction of travel. Then something happens at 1, the acceleration changes. Right? And from 1 to 2, the velocity is still negative, but the acceleration is positive. since they're working against each other, it's slowing down. And finally, from 2 to 3, the velocity is positive, the acceleration is positive, so it's speeding up. Sloppy speeding, but I've answered that part of the question. Represent the motion during the indicated time interval with a graph. So what we've just done really will inform our graph. But we know this particle is traveling on a horizontal line, and we're focusing from -2 to 3. So we know that from -2 to 0, it is moving to the right. Put 0 here. But it's slowing down as it gets to 0, because at 0 it changes directions, and now it's going to the left, and it's going faster and faster for about a second, and then it slows down. So it hasn't changed directions yet, but it will change directions when t is 2, and when t is 2, it keeps going. So our graph looks something like this.